Hello guys, welcome back to Infinite Insight Geometry, Lesson 2.1, Segments. Alright, let's begin. So, before we start talking about segments, we first have to talk about dimensions. There's the first dimension, length, the second dimension, width, and the third dimension, height. We're just going to focus on the first two dimensions. A point is a position in space. It doesn't have a direction and it doesn't have a weight. It's just a point and a location in space. Now, lines are infinitely straight paths. They're one-dimensional, meaning that they do have length, but lines are infinitely long, and meaning that they have an infinite amount of points, but they only go in two directions. The original direction it's pointing to, and the opposite direction. So you can see here you have point P, and then in the line you have point X and Y on line L. Now a plane is a flat surface. It's two-dimensional. Think of a shape, like a circle or a square, except it spreads out infinitely in all directions. So all of those points and lines make up the plane. Any 3 points can make a plane, as also any 2 points can make a line. So any 3 points not on the same line can make a plane, because you can form 3 lines, and those 3 lines also intersect to make a plane. And we call that plane R. So we have points A, B, and C, and we can label it plane R. Now, if you have 2 random points on a plane, you can connect them with a line. That segment has a measurable length. Now, look at this line segment here. This is line segment CD. Now, if you extend this line segment infinitely, this will be line CD. But since there are only 2 points, and we're connecting them with a line, the length between point C and point D has a measurable length, which is 5 centimeters. So all of the blue text that you see on the screen, also in the past slide, where you had the points, lines, and planes, those were definitions. Point, line, and plane are definitions for this topic, as with the other definitions that we'll go through here. Line segments, they are a portion of a line with a finite length. So line segment CD is a portion of a line, and it has a finite length of 5 centimeters, as we can see. And the endpoints are just the points at the ends of the line segment. So line segment CD's endpoints are point C and point D. Congruency. Congruency is to be equal, so congruent segments have equal lengths. They are usually marked with matching tick marks. So as you can see on the screen, AB, line segment AD is congruent to line segment CD because they both have a length of 6. And we denote that by making 2 tick marks on each of the line segments to denote that they're equal. So, we went through all the definitions, and for lesson 2.1, we have points, positions of space, lines, infinitely straight paths, planes, 2D surfaces extending in all 2D directions, line segment, a portion of a line with a finite length, endpoints, the points at the ends of the line segment, congruency, to be in the same length, size, and shape, and congruent segments, line segments that have equal lengths. Now, these are definitions. But note that to solve a proof, you also need not just the given statements and definitions, but also postulates and theorems. And one of those postulates we'll go over right now. The segment addition postulate with the cyan, green, turquoise color. This is the color we'll use to denote postulates and theorems. If points A, B, and C lie on the same line, and B is between A and C, then the segment AB plus the segment BC equals the segment AC. And it's not that hard to understand because, well, if you draw a line and you add the lengths up, they will obviously equal the bigger line. And this might seem like common sense, but this is really an important part of mathematics, making sure you have all your bases covered. So when you need to prove something, you can say this and it will work. For example, given that n, m, l, and k are on the same line, find the value of x. So you can see that there are points n, m, l, and k. They all have given lengths, and the entire length of the segment is 23. So how will we go about solving this? Well, n, m, l, and k are on the same line, and the whole segment is the sum of its individual parts. So we could say that nk equals nm plus ml plus lk, and then substitute all of the values. So here are all of the statements and reasons that we need to conclude that this value, this x value, is equal to 13. So we had the statements and the reasons. First, we start off with the givens. N, m, l, and k are on the same line. We were given that. And so using the segment addition postulate, we can conclude that nm plus ml plus lk equals nk, because the whole segment, nk, is equal to the sum of its parts, nm plus ml plus lk. And then we can just substitute the values that we see on the diagram. X minus 6 equals nm, so we can plug that in for nm. 9 equals ml, so we can plug that in for ml, and so on. We use substitution, because that's a given reason. We simplify, we add like terms, and then we use the division property of equality, meaning that we just divide both sides by 3, because 3x we have to divide by 3 to get the x alone, which is what we're trying to solve. So using these steps, this logical order that we use to solve a proof, we determine that x is equal to 13. And even though you might think that this is really simple, this will get much harder over time, because we have a lot more proofs coming up, and this is just the baby steps. This is the foundation in which we use to build other proofs. And the segment addition postulate is one of the baby steps that you really need to learn to be able to solve proofs. And that will be all for today's video. If you like the video, please like, comment, and subscribe. I have my Gmail down below. If you have any questions, please feel free to email me, and I will see you all next time.